just got back from Build 2019, where I talked to Laura Edell about a variety of topics, including machine learning at scale with SPARC, and her NCAA Final Four prediction model. Before we get into that, just wanted to let you guys know I recently appeared on Undersampled Radio, episode 88. You can check that out for a casual discussion of some machine learning topics and things I'm working on and that sort of thing. All right, let's get right into our interview.
My name is Laura Edell. I am a senior data scientist and cloud solution architect on our national team. So I support Azure in all of its machine learning, deep learning, AI type projects for our customers. In terms of affiliation, I've been at Microsoft now 3 years. I've been doing data science for my entire career. Came out of school with a degree in quantum physics and then statistics, which is how I got into this path, and I'm currently working on my advanced degrees.
What in particular are you studying?
Right now, I've just started my program, so I haven't picked.
Sure,
so,
fair enough.
Yeah.
I'm curious about the ways in which you're seeing customers use machine learning in the cloud. Are there any surprising use cases or trends you're observing?
Right now, I think customers it's a very hot topic. Everybody wants it. They don't really know why they want it, but they feel like it'll help their business. And so one of the most exciting for me use cases with a customer that I just finished working on started with an image recognition. So you can imagine having machinery, and they wanted to be able to have their techs who wear body cams have objects detected from the machinery without them having knowledge prior about that part. So things like I scan this, let's say it's an HVAC system. I now know it's a valve. I know the valve number. Here are all the documentation that goes with it. So now that tech, whether they have 30 years or 1 year in the field, they look like an expert. But what's even more interesting is this idea of augmenting it with audio signal processing from a deep learning perspective. So picking up the sounds like the tick, 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 and being able to say, oh, that fan sounds like it's on its last legs, because we can detect the anomalies in the wave patterns. That bridge of marrying what is, started with image recognition to then sound recognition, and with mixed media from, more of the body cam / HoloLens perspective, that's an exciting use case for me.
My ears are not so good that I could tell you from the tick, tick, ticks if my HVAC was good enough. I guess I need more training data, but how do you acquire it?
So that's a great question. At my session yesterday at Build, I played 2 sounds for the audience, and I said, what do you think these are? And, they sounded almost identical, but the first one was my son blowing on his arm, and the second one was an HVAC system. And so what the great thing is about data science being so popular right now is the corpus of training data that is available to us publicly is huge. And so there are libraries provided by folks like MIT, Berkeley, that are just millions and millions of sound effects that occur naturally in the environment or in machinery, engines, and so forth. That gave me the ability to take an existing training set and use something like active learning and transfer learning to then apply my custom sounds to it, to then have, a training set that I could apply to my business case.
So you've got, I guess, taking the transfer learning, you can build your initial embedding or whatever you're working with from those libraries and then extend it, which is great because you probably have a smaller data set of the negative cases.
Absolutely.
Do you have to then generate that, or is that something that a partner has available, or how do you come by that?
No, and in this use case specifically, we were working with somebody who also didn't even have the images. So, you go into something assuming they're going to have a catalog of all their parts, and that's something we can tap into, and not everybody has that. And so they're just now building it. So we had to start from scratch. And in order to do that, you don't want to tell the customer, hi, I need 50,000 images, and I need it by next week. Or I need 50,000 sounds. And so in our case, the great thing about machine learning is you can take a few of something that is real, and you can augment it by doing things, on the image side, like rotating, zooming, Gaussian blur. You can cut out and zoom into the photo, and you can cut out the backgrounds. On the sounds, it's the same thing. You can smooth out the sine, so how the amplitude goes up and down. You can take out environmental noises, the pauses. So the pauses in sounds are just as important as the active points within that sine. So there's a lot you can do to create your own training data based off of some real sets that they give you. So customer gave you 10. We can turn 10 then into 30 to 50, which is what we basically need per class in a model.
And how does active learning play into it?
So, from my perspective, active learning has a few different meanings. So it is this application more of reinforcement. So you're looking at a model over time that can train itself and then retrain itself. And why that's important is because I think as customers are going through deploying, let's say, a classification model where they now know, this is something that is going to break. This is something that's bad. This is an anomaly, fraud, whatever it might be. There is this perspective down the line where you have to have a life cycle that then can say, hey, what happens when things change? Do I need to manually pick that up and then retrain? And that's to me where active learning comes in, is where you can apply some basic principles to go out and then say, I want to retrain this over time so it has its own logic, if you will, to become smarter. That active sort of working with it and then applying more of a semi-supervised, meaning a partially labeled approach, I know my business the best, to this, so I can work with this system, I think is one of those great use cases of machine and human learning together to make something more powerful.
So in a case like this, how do you decide on what diagnostics or metrics are appropriate for evaluating, is my model to the point where I'm ready to deploy it?
It was interesting on the sound side. So I was a DJ for a while, so I have a lot of passion around music. And so I had a feeling, on some of the sound signals, what would be important. So you're looking at things like time, so the frequency patterns. So how fast does it run? What does the wave look like? How many active points are there? How many quiet points are there? And all of this together, when you lay it out graphically, if you know what a sine wave looks like, it looks like an up and down, smooth line, you can overlay that with the patterns of noise and create that reflection of, this is what a positive set would look like, this is what a negative set would look like, and those things in between become what we want to capture and measure. So to find the evaluation metrics, it's just, standard of what you would look at across any models. You want to come up with a set that's not just one. I hear a lot of people talking about accuracy, and I think, that's a red herring oftentimes, because you'll come out and say, oh, I've got 99% accuracy, and, it's probably an overfit model is the first thing I think, unless I see that test set. So I like to look at, again, a library of metrics around, my confusion matrix. What are most importantly, what are some of my false positives? What are some of my, true negatives? Those things that are miscategorized, if you will, because those to me are way more important than how well we did at categorizing it, which is important. But yeah, that's the kind of things that I look at.
So there's a debate going on about deep learning, and especially in like audio. Do we need to do a lot of feature preparation, some of those transformations you'd mentioned, or do we want to force the machine to figure it out on its own? And I guess probably the best answer is somewhere in the middle, but and maybe even changing with time. What are some of your perspectives on execution in that regard?
Featureization to me is one of the most critical steps. And so do we let the machine do it or not? I think that with the compute power that we have today in the cloud, we have the ability to let the machine do it. And so I'm a big believer in the machine route. Having said that, I'm also a big believer in the business domain expertise that people bring to this. If like, for example, I have a Final Four NCAA model that I just put out at Build and was showing some folks. And, I had my feature importance set. And I said the number one feature importance was wins. So even though that's your gut reaction, like, aha, I was like, okay, that's good to know. Second one was strength of schedule. Am I playing the weakest team? Third was location, home court advantage. So it's like you see this and you're like, that's great. My gut said those were the things. And that's where a business domain expert, may have that knowledge and just let the machine validate it. Even if nothing else, that person will feel like, great, I knew that, I'm working with the model. There's a lot of, I think, sensitivities around how we approach machine and AI from an ethical perspective and a human perspective that we have to take into account that not a lot of people talk about. And these are folks that are invested in this from an analytical perspective, and they have a lot of just that domain experience that you really want to sort of bridge into what you're doing from an ML perspective.
Absolutely. I'd love to dig more into the NCAA project, but one footnote before we get there. In a case on the business side where a data scientist goes to present that model and they say, what are the number one indicators of customer churn? And the first feature is that the account was committed as an act of fraud. And the first 5 things are known, obvious things. Some executives might say, like, why am I paying you for this?
That's a really good point.
Do you have any advice for a data scientist who's in that position and how they teach their model?
Yeah, no, that I've actually experienced that a bit prior to Microsoft as well. Why are we paying you? We knew this. Okay, that's great. When you're talking about business drivers, and especially in, say, a forecast case where you're projecting out your revenue for next quarter, is it a bad thing if I'm now telling you that, yes, those drivers and levers that you're investing in your business, those teams you're building up, whatever it might be, are actually affecting revenue, and we're now validating that from a quantitative, this is no longer a gut feel. I think that has meaning in and of itself. It's all how you position it. But the more difficult discussion is when you find out that no, those things that executive maybe believes this is what's driving my business, and you find out it's not. Those things are actually having zero impact. And that's the delicate discussion you have to have, because there are sensitivities, again, with the human interaction with data. And so, the way that I've always approached that is, putting up the data and having a discussion around it. You have to have a challenger mentality just in life in general. You can't just sit idly by and agree, because it's a more comfortable place to be. There is a way to broach these things delicately. And if you just let the data talk for itself, you can have some arguments about it. You may have captured it wrong as the data scientist. You may need to go back and make sure some things are correct in your assumptions and some of the parameters that you've used. But it's still a discussion at the end of the day that is worthy of having. And at the end of the day, by having a more accurate forecast, that executive looks more like a hero downstream anyway.
Absolutely.
So,
well, good advice. And then back to our NCAA
Yes.
project. What sort of data set do you begin with? I'm aware that there's, if anything, a deluge of stuff tracked now. Where do you get started?
Many years ago, I started down this sports ML passion of mine because my father-in-law said statistics could never outrun sort of his experience in football, and I knew nothing. So I used that like the gauntlet was thrown. Okay. And he was right year one because I was training and I failed. But since then, I've had a lot of success. And so going into NCAA and March Madness, it was an extension of that. And yes, there is a deluge of sports data that the sports bettors across the world have been using for years. If this is how folks from NCAA are looking at their data, let me start here with these data sets. Who are the teams? What are the tournaments? What were the win-losses from the previous seasons? What are the schedules? But then I also have what I think is like a secret sauce that I add to that, which is something I call the player social index. And so I also go out and scrape social spaces, commentary that's made, video feeds, looking at emotion detection, because I had a hypothesis that going into game day, if you've just had a baby, or if you're in the press for negative things like you've been arrested, those things all affect your mental game status on that day, and there should be a weighted index. It may have been my own bias coming into it just because that's what I believe, but as it turns out, they were very strong indicators in terms of future importance, was this index of social strength of that player. And so I add that as well to the NC side, and then we come out with basically a probability of which team's going to win or lose during March Madness, which is a zero-sum game. You have a winner, you have a loser, and that's it, you're out.
Thanks to this week's sponsor, Datadog. Datadog allows you to see all of your system metrics in one place. I was going to rattle off a list of all the services they support, but there's really no point. You'd be hard-pressed to find a service not on that list.
Being able to see across all these different data sources in one spot is one of the great selling points of Datadog.
That's Homan Lee, lead data scientist at Datadog. We recently talked to him about a very interesting twist on machine learning that they had to deal with at Datadog. But before we get to that, let's touch on the use case. DevOps people should already know about Datadog, so ask your colleague for more details, but essentially, they provide visibility into your production system. These days, that's more than just CPU and memory profiling. You need to know about response times, auto-scaling activities, maybe some custom events, and the list goes on and on.
If a data scientist happened to have a service running in their organization doing data science things, it could use Datadog to make sure that it was running well, and if there were any problems with it, they could use that to help figure out what's going wrong.
All right, now to the interesting twist I mentioned. On top of the monitoring services Datadog provides you, they also have forecast, and they had to make a very interesting accommodation to deliver that service.
So people want to use forecasting for something like their disk usage. They want to be alerted if their disk will get full to 100% in like a week, so that they have like a week to deal with it. Customers send us system metrics for how their systems are doing, and they want to forecast where it goes. We have all this historical metric data. We want to train a model that can forecast that historical data as well as possible, but we found in fact that that's actually not the right thing to do. If we try to forecast that metric, we'll in fact actually predict that your disk usage will go up and up and up, and then it'll suddenly plummet. The reason it plummets is because you're actually going to do something about it, but that's not the forecast the user wants to see. If you have your disk metric slowly creeping up, you would want to just extend that out and have it hit 100. That way the user can easily interpret that and say, okay, this will hit 100 if I don't do anything about it. Because the use cases for forecasts are things like setting up monitors on when things are going to fill up, we can't train our models on the past data entirely, because if you do that, you're just going to keep forecasting that people are going to eventually do something about the problem.
At Datadog, they're experts in this area. Let them solve the hard problems of monitoring for you.
At Datadog, we're trying to figure out what machines are doing. That's what I think makes the problems that we work on really interesting.
Visit dtdg.co/dataskeptic. That's dtdg.co/dataskeptic.
And let's talk a little bit about the underlying technology. How do you build that model? And
Sure.
does it get deployed? What are some of its operational characteristics?
So I chose to use Azure Databricks because I come from a Spark background, so I feel very comfortable. I'm a Python scripter. That is just what I do. I'm not knocking R. That's another strong scripting language. I know I have this philosophical argument with folks all the time. But for me, I chose to go the Spark route. And so, yeah, from an underlying technology perspective, I used Azure Databricks and I stored it in Blob. And so I tried to make it, because I understand that from a compute perspective, spinning up these VMs can be costly. But, if you do it smart, as you're computing it as limited as you need to, and then only augmenting or active, retraining it on a just-in-time perspective, you can really sort of control that cost, and then deploying it as a Docker image so that it's much easier to maintain and turn the libraries that I'm using and that are brought in, because there are a lot of actually publicly available bracket, for example. You want to visualize the actual brackets. Folks have already done the work to put those out there as libraries, so you can just bring those in and use them.
Interesting. I'd love to hear more about the step where we go from Azure Databricks to the container.
Yep.
I'm familiar with working through a good notebook and coming to some model, and then there's often a question of, okay, what's next? Tell me about that leap and how we get to the container.
There's a couple ways to do it now. Even Databricks has something called MLflow, which enables you to really operationalize that model. But from my perspective, after you have, you set of scores for your model, you have that training set done. That training set, along with, the .py files that come with it, so basically a score.py, if you will, source data sets, whatever that source data you're using is, all gets grouped together. And Azure makes it very easy then within that notebook framework to then call on the Docker APIs that you can then pass through and say, now build me an image. So you can send through, or, even if it's ACI or, which is Azure Container Instance, whatever it might be, you're passing that through so that your image gets built all in line with your, say, notebook. And therefore, then you can even implement things like Azure DevOps to have more of that DevOps end-to-end experience for checking in, having the version control, all the great things that come with having a true DevOps pipeline.
Those tools are evolving right now. One of the ones that caught my attention is the Microsoft Machine Learning for Spark framework. Could you tell me a little bit about what it is?
So the machine learning services in Azure are evolving rapidly right now. And so by bringing in Spark into the framework, it's really Microsoft recognizing that Microsoft's an amazing power with a lot of tools that we offer to do things. But one of the things that I've heard in the field from customers the most is, what do I use for when? And I think what Microsoft Machine Learning for Spark is doing is it's taking these libraries that have been available to us and adding an abstraction layer on top of it to enable customers to have that framework of Azure. So having the backbone, having the networking, the security, all those great things, but then being able to leverage those Spark libraries natively through this abstraction layer. And so it brings together, and now with things like machine learning visual interface, where you have that really drag and drop, low, no code environment, now you can harness the power of Spark, distribute and parallelize your queries, meaning run them across many machines that you don't have to worry about maintaining, while then on top of it, dragging and dropping and building machine learning models that are incredibly power leveraging that Spark backbone. So, it's a great marriage of these technology sets that have previously been very disparate coming together.
And what sorts of things does it package up? Everyone's got their favorite algorithm, right? What am I going to find if I use the library?
So you're going to find a lot of the same algorithms that you're going to find today that are supported by Spark ML, for example, which is the Spark Machine Learning, or Spark ML Lib, the former machine learning library. You're going to find those same algorithms, but on top of that, you're going to find some of the Microsoft research algorithms that they've created through even things like, or similar to, our CNTK, or our computational, neural network technology, some of the Onyx, which is some of our packaging and deployment of our modeling capability. And so if these are technologies you've not heard of, I highly recommend going out and using a search engine of preference to just research more about them. Because really, if you think about the deployment of models in general, and I talked very lightly about how I've done it with my NCAA, but Onyx really gives you a lot of power for deploying your models and being able to run them in so many different environments, whether it's on the edge from an IoT handheld device perspective to more of your traditional machine learning use cases. But it makes it really easy to deploy that across platform, across different operating systems. And so, it just makes the data scientist world that we typically don't think about much easier for when they need to hand it off to now their DevOps partner, the people that are going to actually automate this piece.
Right.
Yeah.
Have you seen any cases where that's bridged the gap from our data science group to an engineering group who thinks that that's Latin or something?
Absolutely. I think one of the biggest misnomers and one of the biggest gaps that exist today is the data scientists working in this vacuum, and then they come out when they're done and they hand it off. And the DevOps, the automation teams, they have no idea what's happening here, and they think that is this Latin world of like, oh, that's the brain power over here. I think by bridging those two worlds early on in the process through some of the planning and requirements, the DevOps folks can see exactly what's happening in the model space, and the security teams that get worried that maybe too many things are exposed locally to the data scientists. There's so many opportunities to utilize things in the cloud, but the data scientist feels if they agree, they're going to be restricted. I want to have the power to do things on my own. But at the end of the day, everybody has the same wants and needs for their company to have these models built. And by working together and having that handoff, there's such a smoother transition from my model's done. Trust me, as a data scientist, I don't want to maintain that. I don't want to worry about versioning in libraries, and I've overwritten my work now and I've got to scramble and rewrite. Knowing that somebody else now has that checked in somewhere and integrated. I mean, one of the greatest things I showed somebody at a workshop I was hosting for DevOps for Databricks was just the simplest integration of you can integrate with Git or with Microsoft DevOps and have your whole version panel of every change you make in a notebook available to you, checked in somewhere. So you can roll back with, such ease.
Wow.
You don't even have to think about it. And now from the DevOps perspective, they feel better because they can see the changes being made. They can check in the right ones as they build out their full pipelines and know, that they're not overwriting or doing something that's going to inadvertently hurt the other team. That's what working together early on enables you to see and do together.
With tooling like that in place, data scientists can maybe focus more time on the fun stuff.
Exactly.
Are there areas you're excited about exploring in particular, maybe places you want to take the NCAA model next?
Yeah, so I definitely want to take, in general, just sports machine learning to a next level with things like audio. If you have ever attended games in person, there's a lot being called out and thrown, and while they may be coded, 5, 4, 2, 1, blue, whatever it is that they're saying, I believe that there's a pattern there that can be recognized. So I have, because I was a DJ, I have a lot of mobile audio recording devices, even if it was my phone. I want to pick up these things and see if that hypothesis is true, if there's patterns that can be picked up in game call playing between coaches and players, even sentiment. How well, is the coach reacting really angrily? Is that putting stress on his players? We even have monitors in the jerseys now of most teams that we can then monitor and pick up biofeedback. Why not pick up that biofeedback and incorporate that into the model as well? So that player is really not performing as well as they should be. I can tweak my model as I'm running it to maybe place less weights on that particular player as part of their player performance or social index.
All right, so all the football players are going to need to learn encryption when they talk somehow. Is that?
Well, and that is something that, outside of my pay grade, that folks that are in the encryption expert field are working on actively. And
really?
So I'm just looking to take the benefit of the outcome of that work into
bring them
my
the
model.
challenge. Yeah.
Exactly.
Very cool.
Yeah.
Well, where can people follow you online?
A lot of places. So a GitHub, so anybody wants to follow, is Android, ANNEDROID, and that's only because Analytics is my handle everywhere else, and it was already taken. So, and then I also have a blog, which is just my name, so www.lauraedell.com.
Awesome. Well, I'll have those in the show notes as well.
Yeah.
Laura, thanks again for taking the time to sit down with me and share some
Absolutely.
experiences.
This was really enjoyable. Thanks for inviting me.